With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The given question is two batteries of EMF E1 and E2, where E2 is given greater than E1 and internal resistance R1 and R2 respectively are connected in parallel as shown in the figure. Then which of the following statements is correct? Now we have four statements related to the equivalent EMF we have to find. Okay, and these are the given options we have, and this is the circuit diagram where two batteries E1 and E2 with their internal resistances R1 and R2 are connected in parallel between points A and B. Okay, so now let's see in the solution part. So we have the formula for the E equivalent when two batteries are connected in parallel is given as E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. So after solving this, we will get the formula for E equivalent as E1 R2 plus E2 R1 whole divided by R1 plus R2. Okay, and further we have the two resistances in parallel, so we will get the R equivalent for the internal resistances as R1 R2 divided by R1 plus R2. Okay, now see, this is the main formula for the equivalent which we have to deal with this in the question. So now let's say we are having, okay, see, by applying the basic maths, if we have a line, okay, and we have to find the sections it cut. Okay, let's see, we are having a coordinates of the line as x1 y1. These are the extreme coordinates, okay, of the line in which, let's say, some point is cutting the this line section into two parts m1 and m2, and we have to find the x coordinate of this line. Then this x coordinate is given as x1 m2 plus x2 m1 whole divided by m1 plus m2, right? Now see, if I use this section formula for this equivalent formula, okay, see, these two formulas are similar only. Okay, we have the E equivalent also, which is given as E1 R2 plus E2 R1 whole divided by R1 plus R2. Now see, if I draw the line to represent this equivalent formula, so let's say we are having two extreme points which is E1 and E2 here, right? The equivalent EMF cannot go beyond this. I will explain this. Let's say this is the point of E equivalent. Okay, see, one more thing is it is given E2 is greater than E1, so it will be more nearer to the E2 point. Okay, let me draw it again. It will be nearer to E2. So this is equivalent. Let's say this is R1 and this is R2. Now see, from here if we compare this two equation and this E equivalent, so this is the equation, and if we compare, see now the value of E equivalent can go up till point E1, right? Or it will go up till point E2 by changing the values of R1 and R2, right? But see one thing, it will not go beyond this line. Okay, it will be somewhere on this line only, right? It will, this point E equivalent will exist on this line only, okay, between E1 and E2, and it will go maximum minimum up to E1 and maximum up to E2. So from here we can say that E equivalent will lie somewhere between E1 to E2 by using the section formula in the mathematics. So this is the required answer, and from the given options we have A, B, C and D. See, it is given that equivalent EMF is smaller than E1, so this is wrong. Okay, I just said that E equivalent will lie between E1 to E2. Okay, and equivalent EMF E is equals to E1 plus E2. Okay, this is also not in this case. E is greater than E2, this is not the case, and the equivalent EMF E of the two cells between E1 and E2 always. So, okay, it will lie between E1 and E2 always. So option D is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.